Right, the next talk is analyzing data with Pandas by Robin Linderborg. So could we please get a hand for Robin?
Hello. Is this on? Yeah. Hi there, I'm Robin Linderborg, and I'm here to talk about Pandas, a Python library for manipulating and analyzing data. So I have quite a few slides to cover, which means I maybe skip the last few ones in order to also give a quick demo at the end. We'll see. So a few things about me. I work as a data journalist at Sveriges Television, Swedish television. I do some reporting, but I also do a lot of web interactives, data visualizations, and so on. I've been using Python for about 2 years. I learned it through work, where they had this Django framework. And I discovered Pandas about 10 months ago, so not a huge amount of time, but I've learned some things. So let's just get started. Pandas provides us with 2 basic data structures, and these are the structures that you'll be working with almost all of the time. So we have the data frame, and we have the series. And as you can see from this visual representation here, the data frame looks just like an ordinary table. We have the columns, we have the column headers, and we have the index object to the left. We also have the series, which looks very much like an ordinary list, although it also has an index. So to get started, I'd just like to show you how you create data. Normally, you read it from an external source, right? But just for learning purposes, this is. I begin by importing Pandas as PD, which is a convention used widely. So whenever you see PD, it refers to Pandas. And here I create a new series consisting of just a few numbers. This is an ordinary list that I pass to the constructor. And what we get back is this series object with the index that was automatically created for us and the values to the right. The syntax for the data frame is slightly more complex, but it's basically just a dictionary that I'm passing into the constructor, and the keys of the dictionary will become the column headers, and the lists or the values here will become the rows for each column. So this is the result of this operation. So before we continue, I'd just like to show you what this looks like in the wild. So here's the same code in an IPython notebook, and whoops. What we get back is an object that looks like this, and the same goes for the data frame here. So we'll play around with this tiny data frame that keeps track of 2 stores and the number of guitar they sell every year. So the first thing that I'd like to talk about is selecting different bits and pieces of our data frame. To select a column, we use this square bracket syntax, just like you would with a normal Python dictionary. If we want to, and we get a series in return. So whenever you select a column from a data frame, you get a series in return. So the 2 data structures are intimately connected. If we want to select an individual row, the syntax is slightly different. We use the lock method for location, I believe, and then we just specify what index we're looking for. And we get a series in return here as well. Although this time, the original column headers are now the index of the returned series. And if we want to select multiple columns, we just pass in a list of column names. And we're returned with a new data frame, since this is a multi-dimensional object that we're returned with. Selecting multiple rows functions very much like you would slice a Python list. So here I'm selecting the first 2 rows, and I'm returned with a data frame consisting of just those 2 rows. So let's do something slightly more interesting, filtering. Let's say we wanted to get all the rows from this data frame where store 1 sold over 500 guitars, so all those values. Here's what this looks like. And I don't know about you, but the first time I saw this, my reaction was kind of like this. This looks really weird. I mean, I thought it was a syntax error the first time I saw it. And I don't have time to go into the inner workings of this behavior, but it's essentially inherited from NumPy, which is a hard dependency of Pandas. So yeah, you can see that it works. And basically what's going on a high level is the thing we're passing into the data frame within square brackets, the outer square brackets, is it returns a series of booleans. So whenever the value in this return series is true, Pandas keeps that row in the original data frame. Whenever it's false, it drops it. So it does this comparison row by row, and we're returned with all the rows that match the condition that we set up. And the same goes for basic math operations like the thing where you multiply. Sorry. So here I'm multiplying the whole data frame by 10, and what Pandas does is it goes through each cell in the data frame and does the same operation. So you can see here that every cell in the data frame has been multiplied by 10. There's a fancy word for that. I think it's vectorization, but yeah. So one thing that Pandas really excels at is dealing with missing values. Here I'm creating a new data frame with 1 missing value. None gets interpreted as a missing value. And I'm appending that data frame to my original guitars data frame. So essentially, I'm adding a new row to the bottom. So now that we have, so here's the resulting data frame. You can see that in this representation, the non-value becomes nan for not a number. So we can, when we have some, Pandas has a lot of built-ins for dealing with missing values. So one of these is null. When we call that method on the data frame, we're returned with a new data frame where each value is turned into a Boolean. So if it's not null, it's false. If it's null, it's true. We can also use the drop NA method. So if we wanted to drop all the rows in the data frame that contains NA values, we would just say drop NA, and then we have a new data frame with only existing values. If we don't want to drop the whole row just because there's 1 value missing, we can specify how we want to perform this operation. So I just say all, and this means that all the cells in this row has to be none for it to be dropped. So I don't want to throw out the whole row just because there's 1 missing value, perhaps. There's the fill NA method, which, as you might have guessed, it fills the missing values. So here I'm just passing in the number 0, and all the missing values in this data frame will essentially be replaced with the 0. And this also has a nifty method called, you can use the method argument to that operation. And here I'm using the forward fill variant, where it will look at the previous value. So in column store 1 and row number 4 with the index of 3, it says 480, and Pandas will use that value to fill the next missing value in the frame. So the index. Here I'm just grabbing the index from my data frame, and I'm returned with a simple Python list. I can also set the index to be one of the previous columns. So if I say set index year, Pandas takes that years column, puts it in the index, and throws it away as a column. So now if I want to select a specific row, I don't use the ordered index anymore. I use the name that this row has now, which is 2012. If I want to use the order, if I want to select a row by its order in the data frame, I use the ilock method. So here I'm selecting the second row by using ilock and 1 within square brackets. I can also pass in a multi-dimensional object to the setIndex method. And what this does is it creates something that's called, it's referred to as an hierarchical index in Pandas. So now we have 2 levels of indices. The same can be done with the column axis as well. And I think the easiest way to explain what this does is just to show a few examples. So with this hierarchical index, I can now say guitars lock, and remember this is the way we select rows, guitars lock old, and that selects all the rows that are contained in this outermost index. And what we get back is a new data frame where that outermost index has been dropped, and we're returned with our original index, which is the year index. I can also pass in multiple values to this lock method. And if I have a hierarchical index, it will go from the left to the right. And here I'm selecting all the old rows and then selecting again, indexing into the first row by referring to the index of the innermost index. And I'm returned with this series, which is not a data frame, it's a plain series. Okay, there are lots and lots of methods in Pandas for transposing and reshaping data and so on. I won't go into very much detail, but I will mention this one very nifty method called T. What T does is it essentially just flips around your columns and your indices. So yeah, it's pretty straightforward if you look at it for a while. There's also some other methods which I won't be discussing today: stack, unstack, and pivot. Pivot has the same functionality as the pivot table in Excel, if you've ever used that. So let's get into the fun stuff, plotting. First of all, I'm dropping my hierarchical index, because I don't need that anymore. And I do that by saying on the index object, drop level. So Pandas just assumes that I want to drop the outermost index. And I'm returned with my original guitars data frame here to the right. This is how we plot in Pandas. Quite straightforward. Does anyone, I don't know if you can see the text, does anyone notice anything wrong with this plot? Huh? Yeah, exactly. The X, so the ticks at the bottom. Pandas doesn't recognize these as datetime objects, because they're not, they're just integers. So we have this mathematical notation, which we probably don't want in this case. So what I need to do is use the built-in toDateTime method in Pandas. And I pass in the index of my data frame, and I specify the format that I want it to be displayed as. So in this case, it's just a year with 4 digits. And if I do this and then say guitar plot, everything looks okay. But there's one more weird thing with this plot. It doesn't start with 0. Panda assumes that you want to start with a minimum value and end at the max value of your data frame. So I can fix this error by just saying ylim is equal to 0. There are obviously different kinds of plots that you can make. I'm here using the built-in plot functionality in Pandas, which uses is built upon matplotlib. Here I'm just saying, okay, show me the same data but as a bar chart. And there's a rich ecosystem of visualization tools that you can plug into Pandas, and they all have different functionalities, pros and cons. I will just mention 2 of them in brief. So Vincent, I discovered. Has anyone here used Vincent? No? I just discovered Vincent a few weeks ago, and it has some quirks, and the documentation is not super good all the time, but it really displays beautiful graphs, in my view. So it's built upon a library called Vega, which in turn is built upon D3.js. So we have all these layers combined, and you can take your Vincent chart and either display it directly in your notebook, or you can export it as a chart to your website or whatever. Sorry? This one is not interactive. I'm not sure if Vincent has support for interactives. I'll show another one. Oh yeah, so this is the area chart of the same data with Vincent. Bokeh, has anyone here used Bokeh? A few of you, yeah? I haven't used it all that much. I've just played around with it in combination with Pandas. But Bokeh can be used directly in your notebook as well, as long as you pass in the notebook equals true argument. So here I'm using the line constructor, and yeah, quite straightforward. And Bokeh, I think, yeah, Bokeh is interactive, right? Yes, yes. So yeah, you have all these tools, and they have different functionality, and you, at least with Vincent and Bokeh, it's just a few lines of code, and you can start visualizing your data with those tools in combination with Pandas. And like I said, you can here I'm saving my data frame, my visualizations to a HTML file instead of showing it in my notebook. So this gets saved in the same directory as my notebook as foo.html. Okay, so this went faster than I thought. So I think I have time to do my demo. This is a small data set that I grabbed from Cypress ARMS database. So this particular spreadsheet shows military expenditure for, well, I guess all the countries in the world from 88 to 2014, I think. And you can see that it has some, it's not super clean. It has some weird syntax for missing values, and it also uses colors for, I mean, the colors has meaning, which is, yeah. And it has some rows which are actually not countries. So let's see what we can do with this in Pandas. So I'm going to switch over to my notebook here. So I've already written this code just in case. But so here I'm importing the data with the read Excel method that Pandas has. It has a bunch of different, it has support for a bunch of other data formats, of course, like JSON and CSV and so on. So this is the name of my Excel file. And here I'm specifying the name of the sheet that I'm interested in. And boom, load that. And then I use the head method just to get a quick overview of my data. So this is what it looks like without any manipulation from Pandas part whatsoever. So let's try this again, because this is horrible. So I'm importing the spreadsheet again, but this time I'm saying that, okay, so my header rows are contained in the 5th original row. As you can see, so country, yeah. And also, I'm saying that, okay, whenever you see 2 dots or XXX, that means there are missing values. And I also say skip the last 8 rows, because they just contain some meta information about the data. So if I reassign my data frame variable to that import and take a look at it, it looks better. So we have the countries to the left, and then we have all the values for the expenditure in the columns. But we have a lot of missing values here. So let's just first look at how many rows we have in our data frame. We can do that by using the len method. We have 186. So now I want to, my mission here is to drop all the rows that have only missing values. Okay, so for example, Africa at the top here is not a country, so it doesn't have any information in the year columns. But I can't say drop the row if it only contains missing values, because all the rows have a value in the country column, right? Like Africa here. So I need to specify a subset of columns that Pandas looks at when it decides to, when it's deciding which rows to drop. So here I'm creating a new data set, data frame, made up of the columns of the original data frame. So if we would take a look at this. So here I'm dropping the country column, and I'm returned with this new index object that contains all the other columns. And then I can say to my data frame, drop all the missing values, and I use the how_all method argument, and I specify the subset of columns that Pandas should consider when dropping rows. And I also say, do it in place. So don't return me a copy of the data frame, but manipulate this the same object. So if we take a look at the length of the data frame now, we can see that we have actually dropped 15 rows. And we can inspect it again, and it's starting to look better. We still have missing values, but that's for countries that have data recently or in the past, but not for all the years. So now I expect this to work. So I want to get just the row for the United States. But it doesn't return anything, so why no results? It's because the column, the values in the country column actually contains white space, which is not visible in the preview that we looked at above. So here I'm applying a lambda function to strip each value in the column, in the country column. And if we do the same operation again, oh, sorry, I have to do that. So now it works. So let's say I wanted to plot the military expenditure of the United States as a line graph, as a line chart, and also that of Sweden. Here's how I would do that. So first of all, I would create a subframe containing only the values for Sweden and the United States. And Pandas has this peculiar syntax for the OR operator in a data frame filter. This is I won't go into that. You can't use the or word, and you have to put the different filters within parentheses. Just accept it. So I have my new subframe here. It's not displaying anything because I didn't say it didn't output anything. I also want to delete the notes column because the notes doesn't contain any actual data. And then I'm setting the index to be the country. So yeah, we can just take a look at it. So like I did in the past with the years, remember, I'm now taking the whole country column, putting it in the index, and now I can refer to individual rows by specifying the name of the country, which is convenient in this case. So if I plot this, it doesn't do what we expect. That's because we want to plot it by year, right? We want the x axis to be the years, and the values should be displayed as the y in the y dimension. And this is simple to correct. So before I do this, I'm just gonna create a new cell here, so we can. Okay, so this is what our data looks like right now. If I use the T method, like I mentioned before, remember transposing the data, we get this object in return. And this is something that Pandas can plot like we expect it to. And yeah, and here's the resulting graph. Yeah, and I think I'll end with that beautiful chart. Can you see Sweden at the bottom? Thank you. So 2 minutes for questions. Yep. I hope I can answer them.
How does it work with large data sets that probably doesn't fit in memory?
It's very efficient. So I'm not a data scientist. I don't know the internal details of this, but I've read that so Pandas is implemented with NumPy. NumPy is actually written in C, as many of you probably know. So it's very efficient. It can handle huge data sets. I don't know anything about the limits or so, but it's a different world than your ordinary Python data manipulation. Yeah.
What about visualization? Did you use the Pandas built-ins for plotting?
Yeah.
Does it work with Matplotlib as it is, or do you need to use Seaborn or Vincent or Bokeh?
No. So when I say plot, it's Pandas is actually using Matplotlib, right? But you can also create so Matplotlib. You can create an empty Matplotlib figure and then just pass in your Pandas data. You can also pass in your Pandas data to, like I said previous, like Vincent or Bokeh or what were you saying? The library?
Bokeh, Vincent,
yeah.
Seaborn.
Seaborn, right? So Seaborn is another popular alternative. So the data frame has this plot method, but you don't have to use that one. You can just pass in the data to whatever framework, whatever external library you want. It works good with a lot of different ones. More questions or not? One over there.
How easy would it be to change the Y scale to a logarithmic scale instead?
It's probably very easy. I don't know this in.
Please repeat the question.
Oh, sorry. So how hard is it to change the Y scale to a logarithmic scale, so you can actually see Sweden? I suppose it's not that difficult. Let's see here. Here's all the Pandas has this convenient magic function. You just put a question mark before your code, and it shows you the docs. So let's see here. Log y, right? Let's see what that does. So the default is false. Let's set that to true. Oh, sorry. Plot. Oh. So it works. Yeah. Yeah. Thank you. I think we're out of time, right? Yep. Thank you.